Hey everybody, this is continuing our solving quadratic equations, and we're going to use our graphing calculator and be able to find zeros within our table, and to also be able to find zeros by graphing. So let's go ahead and get started. First example, we're going to enter x squared minus 7x plus 12. And keep in mind that if you have a function that is not set equal to 0, that's the first thing that you need to do is you need to get that quadratic equation in standard form. So get it set equal to 0. So I'm going to go ahead and graph this. And you will see here that along this x-axis, this graph intersects the x-axis at two places. And I would like to know exactly where that is. So notice it crosses the x-axis here, where the graph is in a positive y, it crosses and it goes to a negative y. And then over here, it goes from a negative y value, crosses the x-axis and goes to a positive y value. So I want to find what these two zeros are. So I'm going to first go to my table by going to second and graph. And as I scroll through this table, you will notice, what am I looking for? I'm looking for the y values that are 0, because that's where it's going to cross the x-axis. So notice I've got positive y values, I have 0, I have another 0, which means somewhere between 3 and 4 I'm going to have graph that goes below the x-axis. So a quadratic has a degree of 2, therefore there are 2 zeros, a maximum of 2 zeros. Notice I found the 2 zeros here, so I would write my answer as x equals 3 and x equals 4, and that's using a table. Now, if I'd like to go back to this graph, and I would like the calculator to calculate my zeros, I'm going to go to second trace. Notice 0 is number 2. I can either arrow down or I could just click 2. So if I arrow down, I have to hit enter. And it'll say left bound. So really, I got to find this little cursor deal. There it is. Left bound. So in other words, here's the 0. I need to get left of the 0, so that's somewhere up in here. I'm going to push enter. And then it'll say right bound. So I'm going to use my arrow, and I'm going to get to the right of the 0. Notice this is the 0 I'm finding. Go to the right of it. And I'm going to push enter. And then I'm going to go back to where I think it is. I just got to go back really one little step there. And notice my 0 is at 3, 4, or at 3, 0. So x equals 3 is going to be a solution, a 0 for this quadratic. Now, the other one, it's right here. So I need to calculate second trace. The 0, this time I'm just going to push number 2. And it'll say left bound. I need to get to the left of the 0. So if this is the 0, I'm getting to the left of it. Push enter. And then right bound, I'm going to get to the right of the 0. Notice I'm to the right, which the graph would be above. I'm going to push enter, and then I'm going to shimmy back to where I think it is and push enter. And notice you get a 0 at x equals 4. So that means x equals 3 and x equals 4 are zeros of my quadratic formula, and all that really indicates is that is where it crosses the x-axis graphically. Okay. So one of the other things that you'd want to do, and sometimes, you know, from a table and from a graph, you can see exactly where they are. So that is a pretty simple example. Let's go a little bit more complex here. So let's enter that 5x squared plus x minus 4. Again, if you have an equation that is not set equal to 0, then you need to set it equal to 0 first before you put it in under your y equals. So let's graph it, and you'll see that I have a 0 here and a 0 here. Okay, I'm going to first start by table. So second graph. So I'm looking at this table, let me get a little above here. You have positive y values, and then it hits 0. So there's my first 0, x equals -1. And then it goes below, so here it shows us that it crosses the x-axis, and then it comes back up into a positive y. So a negative to a positive. That's a sign change in your y values. That would indicate that my other 0 is between 0 and 1. Okay, so my first 0, keep in mind I need 2 of them because it's a quadratic. I'd have at most 2 zeros. First one, x equals -1. But I want to find what it is between 0 and 1. So I'm going to change my table set. Notice this table set is above the window. I'm going to go second window. That gives me a table set. And I said that my 0 was between 0 and 1. So I'm going to have my table start at 0. And then I want my table, instead of it to go by ones, let's have it go by, I don't know, tenths. And I'm going to go to my table, second table. Now notice, I'm starting at 0, I'm going to 1. I'm looking at the y values. Here's a 0. X equals 8/10 is a 0. So my two solutions for this quadratic of 5x squared plus x minus 4 is that x equals -1, and also x equals 0.8 or 8/10. Okay? So those are my two zeros. Now, if I would like to go graphically, I'm going to calculate, second trace, my 0, choosing 2. I'm going to get to the left of the 0, push enter. Get to the right of the 0, push enter. And I'm going to shimmy back to where I think it is, push enter. Notice x equals -1. That's this 0, that's the place where it crosses, the function crosses the x-axis. I need to find this one as well, so I got to calculate that 0 again. And I get to the left of it, and typically you want to be past that vertex, push enter. To the right of it, push enter. And I'm going to shimmy back to where I think it is, push enter. And notice I get 8/10. So that's how you're going to find your two zeros. Now notice that is in tenths. Okay, let's say, let's do another example where answer is not going to be in tenths. Okay, so let me clear this out. And let's enter 3x squared minus 16x minus 12. So 3x squared minus 16x minus 12. Okay, and there's my graph. So, or my function. I'm going to graph it. Ooh, looky here. It looks like maybe this one is going to hit a hash mark at what? 1, 2, 3, 4, 5, 6. And this one is going to be a decimal. Okay, so I'd like to see the whole window. So I'm going to, looks like I need my y minimums. Let's just go say -30, just so you can see that whole graph and what it looks like. Not enough. Let's go back to window, and let's go down and make that a -40. And we'll graph it. All right, there's our whole graph. Okay, notice all I had to do was change the window in order to see the entire quadratic, see the entire parabola. So I'm going to go to my table. And remember I had it in tenths. It stays in tenths until you do your change in table. So I'm going to go to second table set. And 0 is fine, but instead I'm going to just have it go by ones. Okay, and I'm going to go change my table. And notice that if I go up, I have positives to negatives. That's a sign change. So I would jot down on my paper -1 to 0. There's a sign change. And then also down here it goes negatives, and then it hits 0 and then goes positive. That's a sign change, but it already gives us that 0. So x equals 6 is going to be a solution, but I've got to go back to this other sign change between -1 and 0 and find out exactly where does it cross the x-axis, because that's going to be a solution to my quadratic equation. So I'm going to go to table set, and I want it to start at -1 because that is between -1 and 0. And instead of table set, remember before I did it in tenths? If you want to kind of skip a step, sometimes it's best just to go in hundredths. You're going to have to scroll sometimes a little bit more, but at least hundredths is the farthest out we're going to take it. So I'm going to go second table, and I got to get ready to scroll here. So it looks like, notice the y values are getting smaller. I'm getting closer to that x-axis. Ooh, hey, looky there. I've got a sign change. It goes from positive to negative. So I would probably choose the one that is closest to the x-axis, and that's going to be a negative 0.67. So x equals negative 0.67 is going to be our other solution. That goes along with x equals 6. Okay, so use that table set to change your table. And keep in mind it's going to stay that way until you go back and you change it back. All right. That at least gives you an idea of how to solve a quadratic equation using a table, but also to be able to graph it and calculate those zeros.